Chemistry powers today, but courageous chemistry is shaping our tomorrow. It's fueling the hydrogen economy and driving clean energy. It's in our semiconductors and even powers our 5G. It makes bridges stronger and medical equipment safer. Chemistry powers progress and binds us all together. But there's something more that sets us apart. Courageous chemistry.
Hello and welcome to today's lesson. In today's lesson we'll learn how to carry out titration and also calculate the concentration. Okay, now this video I put in here is going to explain the titration process and also the calculation process. All you need to do is just to pay attention, okay, and follow suit. All right,
you can calculate the apparatus needed for titrations looks like this. The pipette is needed to accurately measure a certain volume of the unknown solution into the flask. The burette is then used to accurately measure and add the known reactant to the unknown until the reaction is complete. The burette can measure up to 0.05 cubic centimeters accuracy. To carry out a titration, you follow these steps. 1. Using the pipette, add a set volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Fill the burette with a known solution. 4. Record the starting volume on the burette. 5. Slowly add the solution from the burette to the unknown solution in the conical flask. You may need to swirl the flask to mix, or use a stir plate. 7. Stop adding when the reaction is complete. The endpoint is reached. This is where an indicator may help because there would be an appropriate color change. 8. Record the final volume. 9. Subtract the final volume from the initial reading. This gives you the volume of the solution added. This volume is called the titer. 10. For an accurate experiment, you should repeat this experiment a few times until you get consistent values for the titer. Depending what indicator you use will depend if the color change is gradual or a sudden change. If you are carrying out an acid-alkali titration, you may use a universal indicator which would give you gradual color change, whereas litmus would give you a sudden color change. Sometimes the acid may be the known solution and the alkali unknown, and other times the alkali the known and the acid unknown. So we have carried out the titration a few times and have a consistent titer value. What do we do next? Titration calculations.
2 different examples together and then one for you to try out yourself. These calculations enable us to work out the actual concentration of an unknown solution. So let's look at an example. We have carried out a titration. We started with 25 cubic centimeters of an unknown solution in the conical flask. We then added 20 cubic centimeters of the known solution of concentration 0.5 mol per cubic decimeter to complete the reaction. What is the concentration of the unknown solution? First, we need to convert volumes to cubic decimeters. We do this by dividing by 1000. So, 25 cubic centimeters divided by 1000 equals 0.025 cubic decimeters. And 20 cubic centimeters divided by 1000 equals 0.02 cubic decimeters. Now you need to work out the number of moles for the known solution, because we already know the concentration and volume for this. The number of moles equals concentration multiplied by volume. So in this case, for the known solution, the number of moles equals 0.5 multiplied by 0.02, which equals 0.01 mole. Using this, we can now calculate the unknown concentration. The concentration of the unknown solution equals its moles divided by volume, which equals 0.01 divided by 0.025, which equals 0.04 moles per cubic decimeter. So the unknown solution was at a concentration of 0.04 mole per cubic decimeter. It is much easier to take the time to understand what is happening, but if you prefer to just learn an equation, this is all you will need to know for titration calculations. Using the values we've just determined, we can make use of the following formula. The concentration of the unknown solution equals the concentration of the known solution multiplied by the volume of the known solution divided by the volume of the unknown solution. So, the unknown concentration equals 0.5 multiplied by 20 over 25, which equals 0.4. But you may not pick up all the marks in the test or an exam using this formula because it doesn't show your understanding. Sometimes you need to work out the proportions involved in the reaction by looking at the equation for the reaction. So if we had this question, the balanced equation would look like this. So 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. We are now ready to do the calculations. Convert the volumes to cubic decimeters. 20 cubic centimeters divided by 1000 equals 0.02 cubic decimeters. 40 cubic centimeters divided by 1000 equals 0.04 cubic decimeters. Now calculate the moles for the known solution, sodium hydroxide. The number of moles for sodium hydroxide equals 0.5 multiplied by 0.02, which equals 0.01 mole. Now calculate the concentration of the unknown solution. The concentration of the unknown solution, sulfuric acid, equals 0.01 divided by 0.04, which equals 0.25 mole per cubic decimeter. But from the equation, we know that 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So 0.25 is for 2 moles because we have so far assumed a 1-to-1 ratio. So we need to divide this by 2 to get 1 mole of sulfuric acid. So 0.25 divided by 2 is 0.125. Now here's a question you can try out on your own. Pause the video, work out the answer, and click play when you're ready to check. You get 0.3 mole per cubic decimeter. Here's how you work it out. So using these titration calculations, we can work out the exact concentration of an unknown solution. We have to carry out the titration first, so that we know the exact volume and concentration of a known solution, and then we also need to know the volume of the unknown solution. Armed with this knowledge, we can then work out the exact concentration of that unknown solution.